Hello and welcome to the Swinka exposition in Caracas. My name is Edgar Heil and I want to introduce you to the world of reverse engineering. In our particular case, we have done an AEG breaker and several other breakers from ABB in Switzerland. But on this presentation, we focus first on the general guidelines. So when we talk about this, we have to consider several things. The first item would be, when do we do reverse engineering? We do reverse engineering when the equipment is obsolete and the spare parts are no longer available, or when they are too expensive, when the quantities of the still in service unit makes it economical to do it. The one other very important item is to consider the reliability of the original design. When the original design was reliable, then a reverse engineering of some of the components is usually very economic and can be done. If the original design was not reliable, then we talk about a re-engineering, not a reverse engineering. Re-engineering is extremely expensive and is usually not feasible. However, it is feasible for a few individual components of a circuit breaker, like a valve or a contact or a operating rod. Otherwise, we're talking about reverse engineering of components or individual items. The other item to consider is the function of an item or a system. We have to consider the mechanical strengths, what is originally intended, the electrical function, the existing problems we have to investigate and find out from the customer. One item which is overlooked by many people is, when we do reverse engineering, we like to improve the design. And this is possible with new available materials. If the original item is 20, 30, 40 years old, there is definitely almost always new and better materials available to complete the re-engineering. Now, what do we have to consider for gaskets and seals? Gaskets and seals are classified in three items typically. We have static seals, dynamic seals, or impact seals. Now, the operating pressure needs to be considered. In case of a dynamic seal, the velocity of the movement has to be considered. And then we have to consider, what is the medium we want to seal? Is it air, SF6, oil, other gases? So to improve the design, we have to discuss internally and debate with many other engineers if it's possible to improve the design. Usually it is, because we are using new available shapes of gaskets. The gaskets and seal industry is making great improvements over the last 10 years. So not only the material, but also different shapes of gaskets are available. Another item is the lubrication used for the components. and on the seals. Now let's go to the reverse engineering of the original AEG S1 circuit breaker, which was done by us in work together with Suinka for the old Gaddafi company. What we have to do first is consult the instruction manual and really look at the function of all the items. We have to discuss with the customer the problems and find and analyze the problems. Why did the problem occur? What type of problems was there? In this particular case, we had major problems with the pneumatic mechanism, with the compressor, the dryer, and we had to find alternatives and reliability and difficulties to maintain the existing components. During reverse engineering, we have almost daily internal discussion on how to improve the system. The various engineers involved need to sit together, usually in the afternoon of a day before we go home, and discuss what happened during the day, how can we improve. So between different minds and different ideas, usually a good idea emerges, and that's the way we follow up on the improvement. We had to select a new compressor and a new dryer. We changed the electrical controls. For the interrupter chamber and column, there was no problem and there was no recorded problem, so the only thing we had to reverse engineer was O-rings and gaskets and seals. The picture shows the old motor and the old dual dryer for the compressed air. The dual dryer is a very cumbersome and a very elaborate control needed to create the backflow, the forward flow, the drying time, and we still had an old compressor. So we needed to do a completely different dryer system. Another picture of the dryer and the old compressor. So after due consideration, we finished up with a design looking like this. It was a new compressor. We put a filter in there, which was previously not in the system, and we used a refrigeration type dryer. It was pre-assembled and tested for easy replacement. We only had like 4 or 5 electrical connections to do. The rest was internally wired and controlled. Part of the reverse engineering is to change the controls. Here is a typical diagram. All the shaded in red controls were deleted from the system. It was no longer needed. We provided this drawing in form of an addition to the new instruction manual. The modified electric system, compared to what we deleted, was very small. Only the green items on this schematic had to be added. The rest of the black one could remain For the gaskets and valve design, O-rings, we changed some of the material because it was not quite what we could achieve with the new one. And also for the medium SF6 and air, the latest information is better materials. So some of the O-rings were changed, others are not. But the major focus was on valves and impact seals of the pneumatic mechanism. we changed this to a more favorable design. Here are two examples. An example first, one of the main valve, the old plastic type of material used disintegrated with moisture and humidity of the tropical condition in Venezuela. So the new type of polyether we cast in the old piston and machined over to create a good smooth surface. And this new material is hydrolysis resistant. It means it does not disintegrate under 45, 50 degrees Celsius and high humidity. Another example was the pilot valve of the close valve. We changed the old type of plastic, completely disintegrated. So we added a new type of plastic. We changed the color because this material is a little bit harder than the one you just previously saw under the main valve, because the stress on per square millimeter is much higher on the pilot valve than on the main valve. For the O-rings of the pole, the columns and the interrupter chamber, as said previously, we just changed the O-rings and in some cases the impact and dampening seals. Here on the next picture we show the seal assembly, just to give you an idea of how many different components and seals are in a single column and interrupter of a circuit breaker. On the closing valve, we found this section was not even in the original manual. The OEM forgot to put a description and maintenance items for the closing valve. So we created a new page in the book and added the gaskets and seals needed for the closing valve. After we did the overhaul of the first mechanism and the breaker, we completed about 500 operations on the pole. It was very successful, no leaks, no nothing. The customer and Swinka came to Warrendale to witness the test. No, the final item is the amendment and the completion of the instruction manual. So we created a supplemental manual which was added to the original. We included the function of the new compressor, the new aft dryer, and also we included a 2-page kits for the complete gasket and seal kit for a breaker. So after this was done, we delivered the material to Swinka, and to the best of our knowledge, the retrofit was and re-engineering was very successful. Thank you very much for the opportunity to be with you. Bye now.